Hello, everyone. Welcome to A1 Tutor Live class and welcome to the mathematics class. Today, we're going to have the continuation of our topic, which is differentiation. Differentiation. We've had like three classes on this topic, differentiation. That is differentiation part one, part two, and part three. And today, we're going to be having part four, which is the concluding part for the topic differentiation. Part four is the concluding part for the topic differentiation. So in case you are not chance to join us online for the live class, for the first part, the second part, and the third part, you can do well to watch them on the YouTube page. So it is available on our YouTube page. The three parts are available on our YouTube page. Just search for A1 Tutor, A1 Tutor. Then you are going to have the video available on YouTube. So you can go ahead to watch the first part, the second part, and the third part. So today we'll be looking at the fourth part, and majorly we'll be looking at the applications of differentiation, applications of differentiation. And we'll be dealing with questions that are related to the UTME exam, the UTME exam. So let's start with today's question, the first question for the day. Like I said, we are treating the part four of differentiation, which is majorly titled the application of differentiation, the application of differentiation, the application of differentiation. So like I said, we'll be dealing much with the UTME questions. We'll be dealing much with the UTME questions, and I want you to follow attentively. Of course, this topic differentiation is one of the simplest topic in mathematics, especially in the exam UTME. The reason why is because you don't need calculator to solve this topic. All you need is your understanding of the basic or the concept of the topic. Once you understand the concept or the basics of differentiation, you can go ahead to solve any question given to you in the UTME. So the application we are going to be looking at still is connected to the concept we discussed earlier. That is in part one of differentiation. The concept we discussed earlier, the application of differentiation is connected to it. So I'll be referring back to the part one of differentiation. So if you've not watched the video before, please do well to watch it on the YouTube page. So it's going to give you an ease process in understanding the other parts, which is part two and part three. So, like I said, we'll be taking UTME questions, and the first question we'll be taking is a UTME question 2006. So we have a question that has to do with differentiation, but this time around is a question on the application of differentiation. Application of differentiation. So what is the question? The question says the gradient, the gradient of y, the gradient of the curve y, of the curve y equals to 3x squared plus 11x plus 7 at the point at the point x comma y is -1. Find the coordinates. Find the coordinates. Find the coordinates of P. So find the coordinate of P means find the coordinate of the point. We're asked to find the coordinate of the point. And to solve this, we need to first understand the question. What is gradient? Gradient means slope. In physics, we call it slope. In mathematics, we call it slope. And in this topic, it is known as gradient. And when you hear the word slope, it means you are working with change in y over change in x, which is also the y, the x, which is also the y, the x. So when you hear the word gradient, it means the y, the x. The word gradient in differentiation, it implies the y, the x, which is a derivative function, which is also differentiation itself. So gradient means differentiation, which is symbolized as the y, the x, the y, the x. All right, so we have that as gradient. So if I was given that the gradient of the curve is y, the curve is y equals to 3x squared plus 11x plus 7. So the gradient of this curve is the derivative of the curve. What I mean by derivative is the differentiation of the curve. The differentiation of the curve. And the differentiation of the curve is the y, the x, which implies the gradient, which implies the gradient. Now to differentiate this expression, like we have been doing from the onset, that's the concept of differentiation. Let's say I have 4x raised to power 3. I want you to listen attentively. To differentiate is very simple. Just get the hint behind it. All you need to do is to take the power. Please follow attentively. Take the power. The power is what I circled, and the power is 3. Multiply the power with the number beside x. The number beside x is the number beside x is 4. So in that case, it means we have 4 times 3. I said multiply the power with the number beside x. The number beside x is 4. So 3 multiplied by 4. Then repeat the variable. The variable you are given is x. Write x back again. Then the power still remain 3. Write 3. Then you have to subtract 1 from the power. That is differentiation. The subtraction of 1 from the power is one of the important steps you have to take in differentiation. So until I remove minus 1 here, I'm not yet done. So minus 1 is used in differentiation, while plus 1 is used in integration. They are word and opposite. I said minus 1 from the power is used in differentiation, and plus 1 to the power is used in integration. So this is going to give us 4 times 3, which is 12. Then we have x. Remove 1 from 3. Remove 1 from 3. The answer is 2. So this is the differentiation answer of 4x cubed. This is the differentiation answer of 4x cubed. The differentiation response of 4x cubed is 12x squared. I hope that is clear. If yes, please kindly signify with a thumbs up. All right, please, I'm going to give you a question right away to solve, and I want your response quickly. Differentiate this for me. If y equals to 6x raised to power 3, differentiate this for me, and let me have your response quickly. Differentiate this for me. Y equals to 6x cubed. Differentiate this and give me the response, so we can go ahead to continue the solution we are doing. Differentiate y equals to 6x cubed. Differentiate y equals to 6x cubed. I'm waiting for your response. Differentiate y equals to 6x cubed. Just follow the step we did, the step we used in the previous example that I solved, and also do the same for this question. Y equals to 6x cubed. What is the response? Y equals to 6x cubed. What is the response? The response should be 3 multiply 3 multiply this. We have y equals to 6 times 3, then x 3 minus 1. That is going to give you 18x squared. 18x squared. 18x squared. That will be the answer. 18x squared. Okay, let's proceed with the solution we have been solving. That is the UTME question 2006. The UTME question 2006 that we are solving. We are going to proceed with that. Still solving question under the application. The application of differentiation. The application of differentiation. So we are solving a question where we are given the curve to be equals to 3x squared plus 11x plus 7 at a particular point where the gradient, that is the y dx was equals to 1. The gradient that is the y dx was equals to 1. Now we have to solve this by finding the derivative. I told you earlier that the y dx is synonymous to the gradient of a curve. So the gradient of the curve is the change in y over change in x. The change in y over change in x. So let's differentiate this curve. If you use 2 to multiply 3, that is 6, and you have x 2 minus 1. The next number, that is 11x. The power here is 1. Using 1 to multiply 11, that is still 11. And we have x 1 minus 1. Because the power is 1, I'm going to be subtracting the natural 1 from it. Now, differentiating 7. Okay, if you join us for the second part of differentiation, we're able to make justice that the differentiation of a constant is 0. The differentiation of a constant is 0, meaning that the differentiation of 7 would be 0. 7 is a constant. A constant is a number that does not have letter beside it. It's as simple as that. A constant is a number that does not have a letter attached to it. So 7 does not have x, so it's called a constant. So if we differentiate 7, we are going to have 0. We are going to have 0. We are going to have 0 as the response. All right. So with that, we are going to have 6x. After subtracting 1 from this, we are going to have 6x plus 1 minus 1, that is 0. X raised to the power 0 is 1. So we have 11. The y dx is equals to 6x plus 11. 6x plus 11. We'll go ahead to substitute this value into this solution. The y dx was given as the gradient in the question, and the gradient is minus 1. So if I change the y dx to minus 1, I will have minus 1 equals to 6x plus 11. Collecting the like terms, if this guy plus 11 moves to the other side, I'll have minus 1 minus 11, which is equals to 6x. That is minus 12 equals to 6x. All right, minus 12 equals to 6x. Dividing both sides by 6, we have minus 12 over 6 equals to minus 6 equals to 6x. 6x over 6. 6 will cancel out 6. We have x equals to minus 12 over 6. That is x equals to minus 2. X equals to minus 2. Now we've gotten the value of x to be minus 2. We need to get the value of y. Because the question is to find the point x comma y, that is the coordinates of P. The coordinate of P, x comma y. We've gotten x to be -2 from what we solved earlier. Now, how do we get y? To obtain y, which is the curve, substitute x equals to -2 into y equals to 3x squared plus 11x plus 7. So you are going to be substituting the value of x to be equals to -2 into that expression. So we are going to have y is equals to 3 in brackets. Now x is -2 now. Replace x with -2 in bracket, close the bracket, raised to the power of 2. Okay? Plus 11 in brackets -2. Then we have plus 7. Plus 7. We go ahead to simplify. This is 3 into brackets -2 all raised to power 2 is going to give you 4 plus -2 times 11, that is -22. Then we have plus 7. Y will now be equals to 3 times 4. 3 times 4, that is going to give us 12. Minus times plus, that is -22 plus 7. Simplifying this, we are going to have y to be equals to -3. -3. Therefore, we've gotten the coordinates. Take note, x equals to -2 and y equals to -3. So coordinate P is equals to -2, -3. Looking at this, x comes before y. X comes before y. So we have P coordinate is -2, -3. I hope this is clear to us. If yes, please kindly signify as we take the next question under applications of differentiation. Kindly signify if this question is clear to you. If the solution to this question is clear to you, please kindly signify. If I can also see the board, please kindly signify so we can move on to the next. All right, so we can take the next question. The next question. Question number 2, still under the application of differentiation. Application of differentiation. The application of differentiation. So we have the application of differentiation. The next question we'll be picking, still under the UTME exam. We have 1995 UTME. 1995 UTME. What is the question saying? Find the gradients. Find the gradients of the following. Find the gradient of the curve. Sorry. Find the gradient of the curve y equals to 2 root x minus 1 over x minus 1 over x at the point x equals to 1. At the point x equals to 1. Find the gradient. When you hear the word gradient, what should come to your mind is the y, the x. I've said it earlier that in physics, change in y-axis over change in the x-axis is called slope and is also called gradient. In mathematics, we mostly use the word gradient and slope. When in physics, we stick to the word slope. So when you hear the word gradient, it means the change in y over change in x, which is also known as the y, the x, the y, the x. So that is what we are asked to do here. We are asked to find the y, the x of this curve. The curve given to us, which is 2 root of x minus 1 over x, the y dx of this expression. But before we do that, let's first simplify the question itself. Okay, let's simplify the question itself. Y is also equals to 2 root of x means x raised to power 1 over 2. If you agree with me, it means x raised to power 1 over 2. And 1 over x also can be expressed as x raised to power minus 1. X raised to power minus 1. 1 over x can also be expressed as x raised to power minus 1, which is applying the knowledge of indices. Applying the knowledge of indices. So with this expression now, we can go ahead to find the y, the x, the y, the x of this expression. Use this 1 over 2 as the power to multiply 2. That is in bracket 2 times 1 over 2. Close the bracket. X raised to power 1 over 2. Then remove 1 from the power. That's the general process of differentiating a given expression. Then next we have minus 1 multiply what we have beside x. And of course, beside x, we have an invisible one. So we have 1 times minus 1. Close the bracket. X raised to power minus 1. Then the natural minus 1 of differentiation, which is minus 1. So we'll proceed with the y dx, the y, the x to be equals to, if 2 cancel out 2, we are left with 1. Okay? And if we are left with 1, 1 multiply x, we have x raised to power. Take away 1 from half. Of course, we are going to have negative 1 over 2. Negative 1 over 2 minus into bracket 1 times 1 is still 1. 1 times 1 is still 1, but there's a minus in the bracket. So let's say the minus in the bracket multiplied by the minus outside the bracket, that is plus x raised to power minus 1 is minus 2. Minus 1 is minus 2. So we'll go ahead to substitute now. We're going to substitute what we are given in the question at x equals to 1. That is, when x is given to be 1, the gradient, which is the y, the x equals to, anywhere we have x in the expression, you'll change x to 1. That is, you substitute x to be the value of what? 1. So that's going to give us open bracket 1, close bracket, minus 1 over 2 plus open bracket 1 raised to power minus 2. So this is the same thing as 1 over 1 raised to power 1 over 2. The law of indices. The law of indices was applied here. Because we have minus 1 over 2, that's why it changed to division. 1 over 1 raised to power 1 over 2 plus this also will be 1 over 1 raised to power 2. Simplifying this, we have 1 over 1 raised to power 1 over 2 is just like saying the square root of 1, which is still 1, plus 1 over 1 square is still 1. So you have 1 plus 1, then the final answer is 2. The gradient at x equals to 1 is what? 2. The gradient at x equals to 1 is 2. The gradient at x equals to 1 is 2. Like what we've solved here, we got the value 2. I hope this is clear. Can we move on to the next question? All right, let's take the next UTME question on the applications of differentiation. The next question. application of differentiation. And now we'll be taking the next question, the next UTME question. That's number 3. The next UTME question, number 3. UTME 2005. UTME question 2005. We have the maximum value of the function, the maximum value of the function f of x is equals to 2 plus x minus x squared is dash. The maximum value of the function f of x plus x minus x squared is dash. Maximum value. Maximum value. That's what we asked to obtain. But take note that at maximum, the y, the x, or f prime x is equals to 0. The y, the x, or f prime x is equals to 0. The y, the x, and f prime x is the same thing as derivative. It's the same thing as differentiation. So what we are saying is that when we differentiate it, we are to equate it to 0. We are to equate it to 0. The differentiation has to be equated to what? 0. Has to be equated to 0. So if I differentiate this, f of x, which was given to be 2 plus x minus x squared, f prime x, it means the y, the x. Okay? F prime x means the y, the x. F prime x means the y, the x. So let's differentiate this. Differentiate 2. The answer is 0 because 2 is a constant. Differentiate x. The answer is 1. That is x raised to power 1. So you bring the 1 here, you have 1, x 1 minus 1, which is going to give you 1. So differentiation of x is 1. The differentiation of x squared is 2x. The answer is 2x. When you differentiate x squared, you're going to get 2x. Now, we said that f prime x should be equated to 0, meaning that I will have to change f prime x to be equals to 0. So I have f prime x is now equals to 1 minus 2x, where f prime x is given to be 0. We have 0. This has changed to 0. 0 equals to 1 minus 2x. 0 equals to 1 minus 2x. By collection of like 10, if this moves to the other side, we have 2x equals to 1. That is x equals to 1 over 2. X equals to 1 over 2. So x has been solved, and we obtain the value of x to be 1 over 2. And that is the maximum turning point. The maximum turning point. This is the maximum turning point. The maximum turning point. So to obtain the maximum value, we need to substitute x equals to 1 over 2 into the function given to us. The function given to us in the question, we are going to be substituting x equals to 1 over 2 into that function to get the maximum value. The maximum value. So if we substitute x equals to 1 over 2 into f of x, then we are going to obtain the maximum value. So let's bring the f of x now. F of x is given as f of x is 2 plus x minus x squared, which is going to be 2 plus x9 is 1 over 2 minus 1 over 2 all squared. And this will be simplified, and we are going to have 9 over 4. When you simplify this expression, we are going to get 9 over 4. 2 plus 1 over 2 minus 1 over 2 all square is going to give you 9 over 4. So the maximum value is 9 over 4. The maximum value is 9 over 4. I hope this is clear to us. If yes, please signify. We are taking the next question under application of differentiation. I want to have your feedback. If this explanation is clear to you, please kindly signify with a thumbs up or drop a message in the chat box. And perhaps you have a question based on this solution. You can do well to drop your question in the chat box, and we are going to attend to it. So any question on this, if any question, please do well to drop in the chat box. And if it is clear, kindly signify with a thumbs up. Can I proceed with the next question? If yes, let's have a thumbs up. Okay, let's move on to the next question. Thanks for your feedback. Let's move to the next question. That is going to be question number 4. And still going to be a UTME question. A UTME question. All right, you are just joining. I will take another question that will explain to you vividly. So stay online and stay connected. VK, stay online and stay connected. We'll be taking another question. So we're going to give detailed explanation to that so you can follow us as we explain. Application of differentiation. Application of differentiation. Now let's look at the next question we want to take. That is going to be a question from UTME 2015. Find the minimum value. Find the minimum value of y. Okay, find the minimum value of y equals to x squared plus 6x minus 12. Find the minimum value of y equals to x squared plus 6x minus 12. To do this, we are going to follow the step. And the first step is to find the gradient. Obtain the gradient. Obtain the gradient. The question is not completed. We have it at dy dx at dy dx equals to 0. We have that in the question. So to obtain the gradient, that is the y dx, we have y equals to x squared plus 6x minus 12. Let's get the y dx. The y dx means differentiating with respect to x. Differentiating with respect to x. Differentiating with respect to x. Differentiate x squared, x squared. The invisible one is here. Take these two and multiply 1. That is 1 times 2. And close it in the brackets. Write your x again. That is x. Then you have to subtract 1 from the power. That's going to give you 2x. 2x. Then we have differentiating 6x. That will give you 6. And differentiating this, we are going to get 0 because 12 is a constant. So when you differentiate a constant, you should have it in mind that your answer is 0. Differentiation of a constant is 0. So we have the y, the x to be equals to 2x plus 6. 2x plus 6. Now equating it to the y, the x is 0 now. So this the y, the x we have here is now going to be replaced with 0 because at minimum the y, the x is 0. At minimum the y, the x is 0. So we have 0 equals to 2x plus 6. Collection of like 10. This goes inside. You have minus 6 equals to 2x. Minus 6 equals to 2x. Dividing both sides by 2, we have minus 6 over 2 equals to 2x over 2. If 2 cancel out 2, we have your x to be equals to minus 3. Because minus 6 divided by 2 should give us minus 3. Minus 3. So now we've gotten the turning point of this curve, but what we need is the minimum value. To obtain the minimum value, minimum value, you need to substitute x equals to minus 3 into the curve, which is into y. So if y is equals to x squared plus 6x minus 12, it implies that anywhere we find x, we are going to substitute x with minus 3. And mind you, it is always advisable to put your minus 3 in the brackets to avoid error in your computations. So you have to put minus 3 in your brackets. That will give you y equals to minus 3 in my bracket, then square, plus 6 in bracket minus 3, then minus 12. Y is equals to minus 3 square minus 3 square. That's going to be 9. Minus 3 square is going to be 9. And 6 multiplied by minus 3, that is minus 18 minus 12. Simplifying this, we are going to get y to be equals to minus 21. Y to be equals to minus 21, which is the minimum value. So the minimum value is minus 20y. Minus 21 is the minimum value for this question. Minus 21 is the minimum value. I hope this is clear to us. So let's proceed. We're going to be taking the next one. The next question. So we're going to be taking the next UTME question. And that question will be the last one. Then after, we're going to have some questions to evaluate ourselves. So we're going to have the next question, like I said. But before that, let's take a pause. If this we want to address people that are watching us on YouTube for the first time, if this is the first time that you are watching our video on A1 tutor page, please do well to subscribe on the page. Subscribe on the page and also click on the notification bell so you're going to be having access or receive notifications anytime we upload videos on our YouTube page. Just click on the subscribe button and do well to also share, comment, and like our video. Do well to share, comment, and like our video. And peradventure, while you are watching this video, you have some questions to ask. The comment section is there for you. Do well to drop your question in the comment section. And definitely, we're going to get back to you with the response to your questions. With the response to your questions. Now, let's go ahead to take the next question. The next question. We have application application of differentiation. Application of differentiation. Application of differentiation. A UTME question 2002. UTME question 2002. The slope of the tangent, the slope of the tangent to the curve. The slope of the tangent to the curve y equals to 3x squared minus 2x plus 5 is dash. Solution, we are asked to find is dash at point 1, 6, at point 1, 6 is dash. The slope. So we are asked to find the slope of this question, the slope of this question at a given point. The point given to us is 1, 6. 1 is representing x and 6 is representing y. Okay? 1 is representing x and 6 is representing y. I've told you that the word slope is the same thing with the gradient. The word slope is the same thing with gradient, and the word slope is the same with differentiation. So what we are asked to do is to differentiate this expression, the y, the x of this expression. So before we do that, let's rewrite the question out. Given that y is 3x squared minus 2x plus 5, the y, the x equals to, differentiating this, we're going to have 2 times 3, that is 6x, minus differentiating 2x, we are going to have 2, and differentiating 5, the answer will be 0. So we have 6x minus 2. Now the slope of this curve at 0.1, 6. That is the y, the x, when the y, the x of the curve when x equals to 1. From this expression, x is equals to 1. Recall that x is equals to 1 because what we have here is x and this is y. So x equals to 1. I need to substitute this back in the expression. The y, the x, which is also my slope, is equals to 6 in brackets. 6 in brackets, 1 minus 2. That is 6 times 1 is 6, okay, minus 2. And that will give us, subtracting 2 from 6, you have 4. So the slope at 0.1, 6 is 4. The slope at 0.1, 6 is 4. The slope at 0.1, 6 is 4. So this is how you solve questions that have to do with the applications of differentiation. The applications of differentiation. So we've been able to cover up the topic differentiation, starting with the first part, which was the first class we had, differentiation part 1. We discussed about the concept of differentiation. Differentiation part 2, we discussed about differentiating with respect to x and also differentiating with the method of differentiation. Differentiation part 2, we still revised how to differentiate with respect to x, and also we did trigonometric differentiation, that is differentiation of sine and cos, tan and sec. Okay, then we're able to discover that when you differentiate cos x, you'll be getting minus sine x, and when you differentiate sine x, you'll be getting cos x, and when you differentiate tan x, you'll be getting sec square x. So I was able to present a table that summarize all of these differentiation value so that you can have it in mind. You can study, memorize, and know them in mind. Because most questions might not need you to actually solve for the UTME. You just have to pick the answer straight forward. And today, in the fourth part of differentiation, we're able to study the applications of differentiation, and we're able to touch the minimum value, the maximum value. Also, we're able to touch the aspect of the coordinates, getting the coordinates of a given curve, which is x comma y, getting the coordinates of a given curve. So the complete videos is going to be available on YouTube. So you can still take your time to watch again. You can still take your time to watch again. So take your time, go to YouTube and download it and watch it. All right. So today is going to mark the end of our live class. Today is going to mark the end of our live class. Do well to revisit all the videos that have been uploaded on the YouTube. Go ahead to revisit. We have close to 120 videos on the YouTube that covers the live class from February to this period that we have presently. So all the videos have been uploaded on YouTube. From February to April today, all the videos are available on YouTube. Just go to YouTube, search. If there's a topic you need to revise again, it's available on YouTube. Just search for A1 Tutor, then search for the topic you are looking for. Then you are going to have it pop up for you. Do well to revisit those videos because part of what you're going to be seeing in the videos are likely questions that are going to come out in your UTME exam. Likely questions that are going to come out in your UTME exam. Now, this is the time that you need to practice the more. You need to practice more questions, practice more past questions. And to make that easy for you, I'm going to recommend the A1 Tutor app. You have thousands of questions uploaded of uploaded on the A1 Tutor app. Thousands of questions, I mean, thousands of questions. We have 15 years gap of past questions available on the A1 Tutor app. So if you want to practice as much as you want, they are all available on A1 Tutor app. Practice questions, use the CBT session to check your improvement, to check your performance, and keep practicing, practicing, and practicing. Do not forget that the UTME does not have mostly new questions. What they do is that they reprint questions from the existing ones. So if you are more conversant with your past questions using the A1 Tutor app, you are going to have a wonderful and excellent score. So do well, take your time to practice past using the A1 Tutor app. And if there are topics that are not clear to you, use the use the channel of A1 Tutor on YouTube to revise the topic. And as well, you have video lessons on the app to watch. You have lesson notes to study, all for you to have a wonderful moment of exam and to ace your Jamb score. So I wish you success in your exam. I wish you an excellent result in your exam. Thank you for your time and thank you for following us on A1 Tutor live class.